Hello students, today we are going to take up the topic solutions. So under the chapter 3 of class 9 ICSE chemistry. So let us start the topic with a very good thought. It is very easy to defeat someone, but it is very hard to win someone. So our efforts should be to win the heart, not to defeat someone. So learning outcomes from this session is you would be able to explain about solutions and its types and solubility of solvents variation with temperature is very important. Solubility of gas in liquid using Henry law, that too is very important. Crystallization and decrypitation, efflorescent and deliquescent substances, Q is missing here, drawing agent and dehydrating agent. So let us start the topic with a very easy and familiar term, that is solution. Solution, you know that it is a combination of solute and solvent. Solute is the solid form and solvent is liquid form, but it's not necessary. Solution can be made from two liquids also. Solution can be made from two solids also. So therefore it's wrong to say that solute is solid and solvent is liquid. It is not actually. If you go to higher classes you will find that. But for the time being you can just consider that solute is which is the present in small quantity, that is solute, and which is present in large quantity, that is solvent. So let us move forward. If you see these two solutions, you can see and very well define that one is homogeneous and second is heterogeneous. Homogeneous means a phase. The composition will be same throughout. Means at the top of the surface, if you see the water, the constituents are same, and the down also constituent will be same. But if you have this salt, muddy water, let us say muddy water is there, and muddy water, you see the mud will deposit at the bottom. So this type of solution would be heterogeneous. And going forward to that, dilute and concentrated. You can see from that, if transparency of the solution is going, that's why it says a concentrated solution. Concentrated solution, we are adding more amount of solute. Okay, and here if it's less amount of solute, that is called dilute solution. Similarly, we are saying in the lab, dilute sulfuric acid, concentrated sulfuric acid. This is the meaning. If water is added in excess, so that becomes dilute. If water is added in small quantity, that becomes concentrated. Now, next is saturated and unsaturated solution. For example, we started with the solvent and add a very little amount of salt. That is called dilute solution. When you keep on adding solute to that dilute solution, it will change into concentrated solution. And at a time when no more of solute can be added to get dissolved in that solvent, so that type of solution is called saturated solution. If you try to add some more solute, what will happen? That solute will not get dissolved and it will settle at the bottom of the beaker. So this means this is a saturated solution. But can we dissolve this excess of solute by any means? Yes, we can do that. We can change the temperature and this excess of the solute can be dissolved and the solution can be known as supersaturated solution. And supersaturated solution, I will give you very clear example. If you go to any sweet shop and if you are buying the rasgullas, so everybody may be having very sweet in taste and all that. Yes, of course. And the sugar present in that, the solvent present in that, the solution present in that rasgullas, that is a supersaturated solution. That is why when this rasgullas are dipped in this supersaturated solution, then the chances of getting decomposed is less as compared when it is outside. So therefore the shelf life becomes more when you dip into the supersaturated solution because there is less of water and more of sugar. Okay, so please don't go and take outside food, you can make at home. Okay, so supersaturated solution. So first was unsaturated, we have discussed, where no more of there we can add where solution which can dissolve more of the solute, means that solution we can add more of the solute. Saturated, where no more of solute can be added at a fixed temperature. Please do remember that. Given temperature. Temperature is an important parameter and it can change the saturation of the solution. And supersaturated solution which contains more of the solute than that present in the saturated solution at a particular temperature. Now, next is aqueous and non-aqueous solution. Aqueous means water is solvent. And non-aqueous means water is not solvent. Water is not solvent. Water is a polar solvent. No, last time also we have discussed that because of the difference in the electron activity between H and O. So here, if water is not used as solvent, then it's known as non-aqueous solution. And some of the solvents you can see here, turpentine oil. When you are doing paint, how you are making it dilute? By using turpentine oil. Similarly, carbon disulfide, sulfur is the solute and this solvent is used is carbon disulfide. Similarly, nail polish. Nail polish to remove nail polish remover is what? Nail polish remover is acetone, and acetone is which solvent? It is non-aqueous. It is known as organic solvent. Okay. So similarly, alcohol, methylated spirit, petrol, oxalic acid, benzene. So these oxalic acid is it's not inorganic only. Okay, it would be polar. So polar non-polar, just they have given some list. Okay, this is not defining differentiating the aqueous and non-aqueous, but here this is also aqueous one only. Okay. Next, solubility of a salt. Solubility of a solute at a particular solvent at a particular temperature is the maximum amount of solute in gram which can be dissolved in 100 gram of solvent at that temperature. Please see the definition very carefully. Here, solvent is fixed. How much? 100 gram. And its temperature is also fixed. Yes, particular temperature. And what we are measuring? The amount of solute. So it means to say that solubility of salt is the maximum amount of solute which can be dissolved in 100 gram of solvent at a fixed temperature. This is called solubility. Please, the definitions you have to write in the same manner involving all the three keywords. If you are not going to do that, you will lose the marks. Solubility curves. It is a graph between what and what? Solubility versus temperature. And here also solvent is fixed. Okay, given solvent. So these are the curves. These curves are very important. Question can be asked from these curves. Please understand it very carefully. Solubility versus temperature in degrees Celsius. And you see from here, this is straight, steep, potassium bromide. It means the solubility of potassium bromide increases with temperature. And here potassium nitrate is more increased with temperature. Sodium nitrate as well as also increased with temperature. Here solubility remains same or almost or little change is there. Potassium chloride solubility increases but to less amount. And here also potassium sulfate solubility is increasing but to lesser extent. And calcium sulfate solubility first increase and then decrease. So three different cases you find here. Solubility varies very sharply with temperature, increases very sharply with temperature. These are the cases. And here almost same or little increase is there in case of potassium chloride, and almost same or little increase. Okay, and calcium sulfate first increase and then decrease. These are the three cases you have to keep in mind. So this is very important. Solubility of gas in solvent. Now you see, let us have the example of Coca-Cola bottle. Coke is you should not drink. The medical people are telling this. You have to follow the advice. And now the Coke, when you open, which gas is coming out? Carbon dioxide. So why can't we need to cap it out under pressure to increase the percentage of carbon dioxide in that Coke? To mean to say that carbon dioxide as such does not dissolve in Coke. What you are doing is you are increasing the pressure to dissolve that carbon dioxide in the Coke, which is a solvent. The point here is the solubility of a gas in a particular solvent will increase. It depends on the pressure. Let us see if pressure is here 1 bar. There are molecules. How many molecules are 1, 2, 3, 4, 5, 6, 7. Okay, and 8, 9, 10. And here you see when you increase the pressure, what is going to happen? See the gas which is dissolved. Here also in the liquid it is more, and which is not dissolved, that is also more. So I mean to say that solubility of a gas increases with pressure for a fixed temperature and for a fixed solvent. So this is Henry law, very important. Henry law states that at any given temperature, okay, mass of gas dissolved, fixed volume is directly proportional to pressure. So volume is fixed, temperature is fixed, and mass of gas is directly proportional to pressure. This is the point. Now, the crystallization. Crystals you can see. If you see, if you go to your kitchen, if you open the refrigerator top compartment, and if you find the ice cubes there, ice cube is also acting as a crystal. Fine. So how to make crystals of sugar, crystals of copper sulfate, crystals of potassium nitrate? How to make? So we have to make first the solution. So solution, you know how to make is solid, solute plus liquid. Okay. And you have to filter off. Filter off means sometime undissolved particles will be there, that will be removed by the same, the method of filtration, and already you know that 9th class also you did. So this solution, clear solution, after filtration we will evaporate, because we want the water should not be there to much extent, water only to have this little quantity only to reduce the volume of solution. So once the volume of solution is reduced, means see there this volume is more, this volume is decreased, and this solution we will transfer over the cold bath. Cold bath means to provide the cooling. So you know that if concentrated solution is cooled, it becomes solidified. And one step more, it is not written here, seeding is there. Seeding means small amount of crystal we will add to that. It will help in the building up of crystals. Like that, for example, you are making curd. You are, after boiling the milk at room temperature, little warm, you are adding 1 spoon of curd in that. So that is also known as seeding. So that is a biological process, but here there is no biological process. Okay. So here the concentrated solution, that is also known as supersaturated solution. When this supersaturated solution is put over the cold bath and allow it to cool at room temperature, after doing the seeding we are doing at room temperature only, and the crystals will be formed. And if any clear solution is there, we will discard it, and the crystal we will remove, or we can do filtration also. Okay. So this is the method of crystallization. The point here is, we are not bothered much of what is the method of crystallization. We are bothered with little definitions which you can be asked for in the exams. Please do remember that. What of crystallization? Fixed amount, very very important word we should write, which is associated. Associated means it's having bonded, and which forms an integral part of the crystal. So these 3 points you should write in your definition. So fixed amount of water which is associated with crystals and which forms an integral part of the crystal is called water of crystallization. And the second definition is decrepitation. So when you heat any crystal, sound is produced, crackling sound is called decrepitation. So any nitrate salt, mostly nitrate salt undergo decrepitation. When you heat copper nitrate, the sound of the crackling sound will be produced, that is known as decrepitation. So next is hydrated and anhydrated salt. Hydrated means the water of crystallization is there. So if you see the example of Na2CO3 10 water here on the screen, so this is hydrated. 10 water of molecule is attached. Okay, and it's loosely bonded in the crystal lattice. So the fixed number of water molecule as a water of crystallization is there, so that is called hydrated salt. And this can be sodium carbonate 10 water, hydrated washing soda, Glauber salt, Na2SO4 10 water, Epsom salt is there, okay, alum is there. So different examples are there, you can refer book also. Anhydrous salt, a salt which does not contain any fixed number of molecules as water of crystallization is called anhydrous salt, like sodium chloride. Sodium chloride we are not writing NaCl dot water. Next is hydrated and anhydrated salt. Just listen and understand the example. If you see 5 water is there, the color is blue, and if it is white, there is no water of crystallization. So this is important that we should mention the word hydrated copper sulfate, anhydrous copper sulfate. Anhydrous copper sulfate means white, and hydrated copper sulfate means blue. And for example, you taken there copper sulfate anhydrous and added few drops of water into it. See here, this white changes to blue. So the question can be asked is, what do you observe when a few drops of water is added to anhydrous copper sulfate? You will say that white anhydrated copper sulfate, which is white in color, changes into blue. So this is what we have to write in the observation. Efflorescent substances. Certain substances loses water when exposed to air of moderate humidity. Humidity, if it is less, it will lose moisture. So that property is called efflorescence. And for example, washing soda is there, Na2CO3 10 water or Na2SO4 10 water. So this 10 water can be lost, sometime partially, sometime fully. So it depends on the humidity. Humidity, if it is less, efflorescence will take place. And if humidity is more, so then deliquescence will take place. See here, there are many substances which absorb moisture. Previously it was lose moisture. Magnesium chloride, when it is present in the air where humidity is more, it will try to gain moisture and increase its weights and sometimes dissolve. So state change will take place. So examples further are sodium hydroxide, solate, potassium hydroxide, anhydrous calcium chloride. So that is the reason these anhydrous calcium chloride, it is having tendency to absorb moisture. So therefore it is kept as a desiccating agent also. Calcium nitrate, ferric chloride is very important name. 10th class also you will do that. Certain water soluble substances, when exposed to the atmosphere at ordinary temperature, absorb moisture from the atmosphere air to become moist and ultimately dissolve in the absorbed water. This point, this underline the word ultimately dissolve in the absorbed water. It means the state is changed. Earlier it was solid, now change into liquid. This is the point. This is the difference between deliquescent and further we'll do hygroscopy. So you see here, if you see this, we have done efflorescent. So on exposure to atmosphere they lose their moisture partially or completely. Examples are washing soda and flour salt. Deliquescents, which absorb moisture from the atmosphere, dissolve in it. It's very important to form saturated solution. Examples are caustic soda, NaOH, KOH, MgCl2, zinc chloride, ferric chloride. Sometimes question is coming, the common salt, when it is present inside the home during rainy season, it gets moistened. Why? So we can write that sodium chloride contain impurities. Which impurities? Magnesium chloride. Small amount of magnesium chloride is there in common salt, which is deliquescent substance and which can absorb moisture and get it dissolved. That's why the salt, the common salt, gets moistened when during the rainy season. Okay. So next is hygroscopy and desiccating agent. Hygroscopy, it can absorb moisture from the air without changing its state. So this is the difference between hygroscopy and deliquescence. Deliquescent state change was there, and here there is no state change. Examples are copper oxide, calcium oxide, copper sulfate, concentrated sulfuric acid. Okay. Desiccants which readily absorb moisture from other substance, or it is used to dry other substances. Examples are fused calcium chloride, fused phosphorus pentaoxide, anhydrous calcium chloride, and quicklime, concentrated sulfuric acid. So this is a desiccator. If you have brought the new water bottles, there you will find the packet of some substance. So this is a desiccant. Okay, silica gel. Fine. So fused calcium chloride, phosphorus pentaoxide, any one of these can be used here to dry the substance. The substance to be dried is kept over it, and below that this is the strainer, and below that we are keeping the drying agent. Okay, or desiccant. So the difference between drying agent and dehydrating agent is drying agents remove moisture physically, and dehydrating it is removing the moisture elements of water in the ratio 2:1. You know the water ratio composition is 2:1 only. Okay, and it represents physical change and it represents chemical change. And here it is used to dry the gases like sulfur dioxide, HCl, and here used to prepare certain gases like carbon monoxide or charcoal, sugar charcoal, by dehydrating action. So this is dehydrating action. You see what is the dehydrating action is? Water is removed from here. If HCOH, water you are removing, what is left out? CO. If you are removing water from here, only left is 12 carbon. So this is what we are discussing, is dehydrating. Okay, so this we have discussed so far. So what we have discussed about the solution, which is a combination of solute and solvent, and solute is present in small quantity and solvent is present in large quantity. We are having true solution, which is homogeneous, dilute solution and concentrated solution. We have discussed saturated and unsaturated. And important point is the temperature we have to keep in mind while writing for any of the definition for saturated and unsaturated. And in regard to solubility, we have discussed that temperature is fixed and solvent is fixed, the 100 gram, and how much solute is added, that is called solubility. And the curves we have discussed, where few examples we have discussed, where some salts which are having increase in the solubility with temperature, like sodium nitrate, potassium bromides, potassium nitrate, and sodium chloride, there is a little increase, potassium chloride also little increase is there, and potassium sulfate also little increase is there, but calcium sulfate first increase and then decrease. And in regard to Henry law, we know that more is the pressure, more is the solubility of the gas at a fixed temperature, and volume is fixed here. And water of crystallization is the fixed amount of water which is associated. Associated means bonded with the crystal, and it's integral part of the crystal. It's not on the surface, it is inside the crystal lattice. Decrepitation, it's a crackling sound produced when you heat a salt. Hydrated, which is having a fixed number of water molecules attached to it, associated is integral part is there. Anhydrous is no water molecule attached, like sugar is there, sodium chloride is there. Efflorescent, when the humidity is more, humidity is less, then water will lose from the salt to the air. That is called efflorescent, and this leads to decrease in the weight of the substance. You can refer table 3.1 for more examples. Deliquescence, so which absorb moisture and change into saturated solution. Hygroscopy, it is absorbing moisture but does not change the state. And desiccants, like the substance which you are using to drying other substances. And drying agent, dehydrating agent, very important definitions are there. So I would like to repeat the thought. It's very easy to defeat someone, but it's very hard to win someone. So thank you very much.